Hello everyone. Let us now discuss how can we solve the problem largest color value in a directed graph. So there is a directed graph of n colored nodes. So there are n number of nodes. Okay. Now we have m edges. Edges are nothing but number which is connecting between one node and another node. So the number of edges are m, right? The nodes are numbered from 0 to n minus 1. So from 0, 1, 2 and then n minus 1 number of nodes are numbered like this, right? You are given a string colors where colors I is a lowercase English letter representing the color of the ith node in the graph 0 indexed. So this is index 0 as the node, and here if I got a b c a b, then right, so a is nothing but the color of node 0. I'm just taking it as a, right? And I might or might not have a connection between node 0 and node 1, but 1 is having the color of b. Now let us see what we need to find out. You are also given a 2D array edges where edges of j is equal to aj comma bj, indicates that there is a directed edge from node aj to node bj. So that means from aj there is an edge to bj node, right? A valid path in the graph is a sequence of nodes x1 to x2 to x3 and so on to xk. So that means we can go from x1. If it is connected, then only we can go to x2. That means the node is connected from x1 to x2 and then to x3 and then to so on till xk, right? So this is called as a valid path. Now such that there is a directed edge from xi to xi plus 1, so that there is an edge from x1 to x2. That means xi to xi plus 1 will be having a edge, right? Directed edge. The color value of the path is the number of nodes that are colored the most frequently occurring color along the path, right? If I take red for 3 times and blue for 2 times and uh, orange for just 2 times. Now here if the path starts from here, right, from here to here and then going from here, so red is present, right? Red color is present for 3 times and the blue color is present for 2 times, and also the orange color is present for 2 times. From all these the most occurring color is red. So the color value of the path is the number of nodes that are colored the most frequently occurring color along the path. The number of nodes that are colored the most frequent color is red. So in this path, the answer will be 3. So the color value of this path, right, will be 3. I think you understood how we will be getting the color value of a path. Now, return the largest color value of any valid path in the given graph, or -1 if the graph contains cycle. Now, imagine something like a graph here to here and then here. So this will be a directed graph, and here we cannot find the color value for this path. Even I have another graph, another unconnected component like this, and this is our graph. If we have a cycle, then we will be returning -1 as the answer. Now let us look at an example. Here I have red color for 2 times, right? Now let me just take you from this node 0 and then I am going to this node 1. Now, what will be the color value of this path? This path, the color value will be 1. Red is for 1 time, and this light blue or something, purple or something like that will be also 1. So, we'll be returning 1. Now, Let us see, this path is just 1. Now, if I go from here, then here, red is here for only one time, but here red is for two times. Now from here, if I go here, red is for two times and also blue is for one time. Now if I go from here and then till here, red is for three times and blue is for one time. So in these all, the number which is greatest, the color which is most frequent is red, and we'll be returning the number of times that red is occurring, which is 3, right? So 3 will be our answer. But without any confusion, let us not get into a simple brute force like DFS, because it won't be working in this case of 1if and 1if, right? So this DFS will not be working. But instead, imagine if I am going in DFS like this and then here to here and then all this path, so it will not gonna work. But what if I use a BFS algorithm? If I use a BFS algorithm, then it will go level by level, one after the another. But there is something like a gap which we need to do something there. Now let us consider this example. Now imagine I have just started with 1. Why? Why we need to start? Why? Start with node node which has in degree. This has the in degree of nothing, right? It has the in degree of 0, right? Why we are starting from there? So if you ask that question, right, imagine there is a graph like this, and instead of starting from here, if you start from here, then you are missing out this node, right? So it might contain the node, this is also of green color, this is also of green color, this is also of green color. So that's why we need to start the node which is at the in degree of 0, which is nothing but the parent node, the ultimate parent node, right? Now as I am starting with here, let us see what happens. Now I have started here, I can go to here or I can go here. Now as 1, there is also another node which is having an in degree of 0, right? Now let us take this 1, and also I have 4 as in degree of 0. Now I traverse through this one. Let us see what happens if I do a BFS traversal there. Now if I do a BFS traversal there, I have 3 and 2, but I have 3 and there is one in degree and then second in degree. There are two nodes pointing to 3. Now here, if I traverse till 3, let us see, right? Yellow is present for just one time. Till here, I am just talking till here. Now, I go here, okay, I go here and do take the parent elements values, all the color values to the child node. I am taking yellow is for one time. Just copy that to the child node. Yellow is for one time. Till now, if I choose this path, if I am choosing this path, yellow is for one time. And when I come to this node, I have blue. Blue is also for one time. Right. Okay. I got yellow for one time and blue for one time. But if I say this won't be our answer path. Why? Because I'll tell you in a few seconds. Now, let us take the same thing again. Yellow is for one time. Here, I am just taking from the parent. Yellow is for one time. White. White is for one time. Till now, if I choose this path, I'll get yellow for one time and white for one time. Now, why I am saying that this shouldn't be getting as the parent node? Why? Why? Because I only got one parent node traversed from this child node. The child has two paths, but I have only traversed one path. So if I write the in degree, previously the in degree is 2, previously the in degree is 1, but I have traversed this from this parent, from this path, then it became 0. Now I just traversed from this path and it just became 1. For now, it's 1. So, what I did at the beginning, start with node which has in degree of 0. Now, I'll do the same thing and push this 2 into some data structure so that I'll get 1 traversed and then 4 traversed and then 2 traversed. Now, let us see why I am not considering getting through this yellow this 3 into our data structure which stores one after one. Now why I am not doing it? Why? Because there might be a chance that I would get some values which are bigger. Right here I only got yellow and then blue. Now, if I go with that, I will only get 1 as the answer. Now, instead, what I just did is taking 4. Now, I successfully traversed 1. Now, after that, I got 4. I need to traverse from the node 4. Now, let us see. From node 4, let me write red is for only one time till here. I'm just talking about 4 till the node 4. I just started there and I have red color for just one time. Now I go from here till here, then I got red, or here I also got red, so number of times I got red is 2. Now after that I am going here which is having green. Now I just take the value from the parent of red is for 2 times. Now I have green. This green is for now till this node 6. I have red for 2 times and green for just 1 time. So let me write something like the same thing here. Now what will be the maximum value now? It will be for sure our red is for 2 times. This will be our maximum color value. But the thing is, after this we'll be pushing this, we'll be making this as 0, then we'll be making 3 again into our queue, right? So here we'll be using this in a queue so that the front element will be pop every time. Now one thing that we should not forget, after when I traversed 4. This 5 is having in degree of 1. This 6 having in degree of 1. This 3 have 2. I have 5. Then this will be having 0. What I am doing in actually the algorithm is I just got 2 and then I just got 4 and then 2. Right? So at 4, what this 4 will be doing? It just go to the neighbor which is 5, decrement the in degree to 0 and push that back into our queue. And what after this 4 I have 2, right? I have 2 and 2 is having no neighbors with it, right? So it will be popped. After that I have 5. After traversing with the 2, then it will go to the 5. 5 is having node to the 6. Now 6 decrements the in degree to 1. This will be popped and then 6 will be pushed back into our queue. Then 6 is having the node, this will be popped and then this will be having 3 as the node, neighboring node. Now 3 has 1 as the in degree and it will become 0, right? Is there any node 3 can traverse? No. When the queue will be empty, we will be stopping there itself. Now the problem is, how can you store these colors? Now the second question you might ask me is how we'll be storing, how we'll be storing the colors. Now let us solve this by taking this matrix, right? What is 1 1, let me name it as matrix 1 blue. Instead of blue, we will be using 1. Why? Because A is for 0, B is for 1, C is for 2. So we'll be using from 0 to 25, right? So from A to Z. Now, what is this 1 of B or 1 1 stores is number of times blue color appeared in a path that ending with ending with node 1. So at node 1, how many times the blue color appeared for maximum number of times. Everything in this matrix will be set to 0. The starting node is 1. How do we know that the starting node is 1? Now here is my queue. This queue will contain the nodes which are having in degree of 0. First one and then 4. Now I have given the in degrees of every node. So I am just starting with 1. I just pop that 1 and let us just increment the color which one have. One has the color of Y. So yellow, right? So go to yellow and increment it by 1. Now, let us see. 1 is having the neighbors as 3 and decrement it by 1. Then 3 is having the color of blue. But as I said, the parent colors will be coming to the 3. Now, 3 is getting the colors of what its parent has. Now, yellow will be incremented by 1. Now, this 3 has a color of its own which is blue. So let me also increment it by 1. Then it will be 1 and then 1. Now I also decremented this in degree, right? Just let go to the node 2. 2 is having something like all zeros. Now do the same thing which I did to 3, right? Decrementing the in degree and then taking the parent values, parent colors. Now, if I remove and increment it by 1, it will be 1. Now, 2 itself has some color which is white. Now, we also need to increment it, right? So, I am incrementing it by 1. Now, till now, everywhere I just got 1. So, without any confusion, let me take the answer. Let me write the answer or max color value is equal to 0 till now. But I just got 1, right? So I just increment it by 1. And there is no other value which is greater than max color value. Now, as I got 2 has the in degree as 0, what will I do? I'll just push that into our queue. Now, let us see. After 1, I got the front element as 4. Now, let us go to the 4. 4 is having the red color and right. Now, 4 is having the red color. Red will be incremented at 4 by 1. Now, 4 is having the neighbors as 5. As I said, the neighbors will get or the children will get the colors of their parent. What the parent got red for one time. Now this 5 also got a color of its own self which is red. So I'll just increment it by 1, 2. Now 5 decremented the in degree of 1 to 0. Then I would take this 5 into our queue. This is popped back already. Now I have the next element as 2. Does 2 have any neighbors? No, not at all. So I just pop this 2 out. Now I have 5. 5. What is its only neighbor, which is 6? So 6 will get all the colors what 5 got. It just got red color from the parent for 2 times. Now 6 itself has some color which is green. Now let us go to the green and just change it to 1. I just incremented it. But if you see, I got 2 which is greater than 1, right? So let me change it our answer max color value to 2. Now I got the same the color which is 6 got and decrement its in degree by 1, then I would get 0. Now, as soon as I got any node having in degree as 0, just push it into the queue, and this already popped back. That means we have already traversed this 5. Now I got 6, the last element which we need to traverse. 6 is having the only neighbor which is 3. As I said, 6 as the parent will give all the colors to 3, right? If I do the same thing, 6 is having 0. If I add 0 to 1, no change. It is just 1. 1 to 0, uh, then it would be 1 plus 0 will be 1. If I add 2 to 0, then it will be 2, right? And 0 plus 0 will be 0 itself. 0 plus 1 is 1 itself. Now, blue itself has got some value or some color. So, blue is having some color and it is already there itself. So, I have for now 2 as the answer, the ultimate answer. So, at this path, we got red as the most frequent color, and the number of times that color appeared in this path is for 2 times, and we'll be returning to there itself. So the algorithm, first thing, take edges take edges into and make it as adjacency list, and take in degree in a vector, push all nodes with in degree of 0 into a queue. So there will be initializing a queue of int, right, into the queue. And then what will I do is until while queue is not empty, we'll be having something like max color value is equal to 0 initially. Now, while queue is not empty, we'll be doing something like going to the neighbors. But before going to the neighbors, we have something like dp, vector of vector int dp, which stores the node and the color, the value. That means till the node, how many times the color appeared. So dp of the nodes are n plus 1, and vector of int, how many colors do we got? 26, and everything is initialized to 0 as I said. Now we need to take this first element int node is equal to q dot front. So q dot pop, that means the first element will be gone there itself. Now we have to get the parent nodes. The parent node will get to the nodes which are the colors which are having with the parents are given to the child. For we'll be having something like for auto neighbor of adjacency list of node, right? So for int I is equal to 0, I is less than 26, I plus plus the dp of node I, dp of node I, sorry, dp of neighbor will get the colors of what the parent node is having, dp of node I. Now, what will I do when I get to the neighbor? I am just decrementing the in degree of that neighbor. So, in degree of neighbor, I'm just no need here. Instead, in degree of neighbor minus minus. Now, if in degree of neighbor is 0, just push that neighbor into the queue. Q dot push neighbor, right? I think it's clear. Now let us see from here till here. So this is how we just solve it, but every time we need to do something like max here, max color value is equal to dp of neighbor I. So this is how we solve the problem. And at the last, if there is another thing we need to mostly uh, doing, like what if we have a cycle. So for that we'll be having the number of nodes. So I'm just creating like visited plus plus, right? Now I am also initializing a visited int visited is equal to 0. So int visited is equal to 0. Why? Visited will maintain how many times, how many nodes we have visited. Now, if n is the number of nodes we are given with, but visited is not equal to n, that means we just didn't go to every node which is given in the uh, graph, that means in the question. That means if we are going till here, so we'll be only going from here to here, that means only we'll be visiting three times, three nodes, but 3 is not equal to 4, so we'll be returning -1 at this point. So only when return visited is equal to n, then only return max color value. If not, we'll be returning -1. This is how you solve the problem, and I have given the code link in the description. Go and check it. And if you like this video, do share it to your friends and do subscribe to my channel. Thank you.